There's a reason why Japanese engines from the 90s are still shattering records and dominating builds decades later. We're not talking about clever engineering tricks or fancy variable valve timing. We're talking about something much simpler and far more brutal: over-engineering to an almost absurd degree. Today, we're diving deep into 5 Japanese engines that were built like they were going to war. These aren't just reliable motors. They're iron-fisted powerhouses with cylinder walls thick enough to laugh at boost pressure, crankshafts that could double as medieval weapons, and blocks so robust that tuners regularly squeeze triple the factory horsepower without cracking them open. Let's start with the king, the legend, the engine that has single-handedly defined what bulletproof means in the tuning world: Toyota's 2JZ GTE. First appearing in 1991 in the Toyota Aristo, known to us as the Lexus GS, before becoming the beating heart of the MK4 Supra in 1993, this 3.0-liter twin-turbocharged inline-six wasn't just an engine, it was a statement. While other manufacturers were chasing aluminum blocks to save weight, Toyota said, "Forget that," and cast the 2JZ block from iron. Not just any iron, a closed-deck design with 7 main bearings and a deep skirt that extends past the crankshaft centerline. The result? A foundation so rigid, so fundamentally overbuilt that it became the stuff of legend. The factory crank isn't cast, it's forged. The main journals measure a massive 62 millimeters, and the rod journals come in at 52 millimeters. These aren't passenger car specs. These are numbers you'd expect from a competition motor. And here's where it gets interesting. Toyota didn't stop at the block. They added piston oil squirters to spray cooling oil directly onto the underside of each piston. The connecting rods? Forged steel. The cylinder head? Aluminum alloy with dual belt-driven overhead cams, 4 valves per cylinder, and a design so efficient that even at stock boost levels, this engine was vastly underrated. The Japanese domestic market cars were advertised at 276 horsepower due to the gentleman's agreement, that informal pact between Japanese automakers to not advertise more than 280 PS, but independent dyno testing revealed the truth. These engines were putting down closer to 300 to 320 horsepower at the crank from the factory. Toyota had built a monster and then deliberately undersold it. The US spec versions received even more robust treatment with stainless steel turbochargers instead of ceramic, revised camshafts, and larger 550cc injectors. Official output climbed to 320 horsepower and 315 pound-feet of torque. But here's the real story. On a stock bottom end with nothing more than a good tune, upgraded fuel system, and a better turbo setup, the 2JZ GTE can reliably handle 700 to 800 wheel horsepower. That's double the factory output without touching the rotating assembly. Start adding forged pistons, upgraded rods, and proper engine management, and you're looking at 1,000 horsepower builds that daily drive without complaint. Push further into the realm of full race builds with billet blocks and extensive modifications, and the 2JZ has proven capable of producing over 2,000 horsepower. There are drag racing 2JZ builds running deep into the 6s at over 200 miles per hour. The secret isn't magic, it's engineering margin. The 2JZ GTE was designed with such excessive safety factors that even at factory boost levels, it was only using a fraction of its structural capability. That square 86mm bore and stroke provides perfect balance between torque and high RPM power. The closed-deck block design prevents cylinder flex under extreme boost, and that cast iron construction, while heavy at over 500 pounds fully dressed, provides a defined fatigue limit, meaning when stressed below its threshold, the block can handle effectively unlimited load cycles without metal fatigue. This is why, 30-plus years after its introduction, the 2JZ GTE remains the gold standard for anyone serious about building a high-power inline-six. It's not the lightest, it's not the most technologically advanced by today's standards, but it's damn near indestructible.
If the 2JZ is the Western world's favorite overbuilt Japanese engine, the RB26DETT is the JDM purists' holy grail. This is the engine that powered Godzilla, the Nissan Skyline GTR, to absolute dominance on racetracks around the world. Introduced in 1989 with the R32 Skyline GTR, the RB26DETT was conceived with one purpose: to dominate Group A touring car racing. Nissan's motorsport division, led by Naganori Ito, made a calculated decision. Group A rules applied a 1.7 times multiplier to turbocharged engine displacement. Rather than build a 2.4-liter and compete in the 4,000cc class, Nissan went bigger, 2.6 liters competing in the 4,500cc class. This allowed them to add the weight of their advanced all-wheel drive system without being penalized. The RB26 shares its 86mm bore with the 2JZ, but runs a slightly shorter 73.7mm stroke for a total displacement of 2,568 cubic centimeters. Like the 2JZ, the block is cast iron, but Nissan took a different approach with the head. Instead of hydraulic lash adjusters, the RB26 uses solid bucket-style lifters, allowing it to safely rev to 8,200 RPM from the factory. The really interesting part is the induction system. While most engines use a single throttle body, the RB26DETT features 6 individual throttle bodies, one for each cylinder. This setup provides instantaneous throttle response. When you step on the gas in an R32 GTR, there's no waiting for a single butterfly to open and air to distribute through a manifold. Each cylinder gets its own direct shot of air. The turbocharger setup is equally fascinating. Twin ceramic turbine T28 turbochargers run in parallel, not sequential like the 2JZ. The front 3 cylinders feed one turbo, the rear 3 feed another. This provides more immediate response than a single large turbo, while avoiding the complexity of variable geometry or sequential systems. Official power output, 276 horsepower, because of that gentleman's agreement. Actual output? Independent testing showed around 300 to 320 horsepower at the crank, just like the 2JZ. Nissan, like Toyota, had massively undersold their creation. But the real story of the RB26's overbuilt nature comes from the racing program. The N1 specification engines, built for Group A and Group N motorsport, revealed just how much margin Nissan had engineered into the design. The N1 block received improved water channeling, upgraded top piston rings, and better balanced crankshafts to handle vibrations between 7,000 and 8,000 RPM. Most importantly, the N1 turbochargers swapped ceramic turbine wheels for steel. Why? Because the ceramic wheels, while lighter and quicker to spool, proved unreliable at the sustained high boost levels that racing demanded. This tells you everything. Nissan knew the turbos would be pushed beyond stock boost. They knew the engine would see sustained high RPM operation. They built the block to handle it from day one. On stock internals, 600 horsepower is easily achievable with proper tuning and turbo upgrades. Start modifying the rotating assembly, and RB26 builds pushing well over 1,000 horsepower aren't uncommon. The famous Nismo 400 took the RB26, bored it 1mm to 87mm, added 4mm to the stroke for 2.8 liters total displacement, and with forged internals and N1 spec steel turbine turbos, produced 400 horsepower, hence the name. What makes the RB26DETT truly overbuild isn't just the strength, it's the attention to detail. The individual throttle bodies, the solid bucket lifters allowing extreme RPM, the cast iron block that can handle boring and stroking to create the RBX GT2 or the legendary Z-Tune specification. Every component was designed not just to meet the demands of a 300 horsepower street car, but to exceed the requirements of a race-winning touring car. The R32 GTR dominated the Japanese Touring Car Championship so thoroughly that it earned the Godzilla nickname at the Bathurst 1000 in Australia. That dominance didn't come from clever electronics or all-wheel drive wizardry. It came from an engine that simply refused to break lap after lap, race after race.
While the 2JZ and RB26 were building reputations in street racing and touring car championships, Subaru was busy conquering the world's forests and dirt roads. The engine that made it possible? The EJ207. Introduced in 1999 for the Japanese market Impreza WRX STI, the EJ207 represents Subaru's most serious effort at building a bulletproof 2.0-liter turbocharged boxer engine. And unlike its American market cousin, the EJ257, the EJ207 featured something critical: From the version 7 onwards, a semi-closed deck design. Let's talk about what that means. In an open deck engine, the cylinder walls are supported only at certain points, leaving gaps that can flex under high boost pressure. A closed deck design provides support all around each cylinder, dramatically increasing rigidity and resistance to deformation. The EJ207's semi-closed deck bridges the gap, providing significantly more support than open deck designs while maintaining adequate coolant flow. The EJ207 displaces exactly 1,994 cubic centimeters, with a bore of 92 millimeters and stroke of 75 millimeters. Compression sits at 8.0 to 1, but here's what makes it special. Unlike the cast pistons found in many performance engines, version 7 EJ207s came with forged pistons from the factory. These are the same pistons Subaru used in their STI Type RA and Spec C models, parts designed for motorsport application being fitted to street cars. The cylinder head features DOHC operation with 4 valves per cylinder, and from version 7 onward, Subaru's active valve control system on the intake cam. This continuously variable cam phasing system optimizes valve timing across the RPM range, improving low-end torque without sacrificing top-end power. Power output sits at 276 horsepower, that familiar gentleman's agreement number, but with 289 pound-feet of torque. And like the 2JZ and RB26, real-world testing showed these engines producing significantly more at the wheels than the advertised crank figures would suggest. The real magic of the EJ207 is its resilience. The semi-closed deck design means the cylinder walls can handle serious boost without flexing or cracking. The forged pistons laugh at detonation that would destroy cast slugs. The symmetrical layout of Subaru's boxer configuration provides a low center of gravity and inherently balanced operation. There are no rocking forces like you'd find in an inline or V configuration. On stock internals with a proper tune, fuel system, and turbo upgrade, an EJ207 can safely produce 350 to 400 horsepower. That's a 50% increase over stock with nothing more than bolt-ons. Start building the engine with upgraded rods, bearings, and headwork, and 500-plus horsepower is easily achievable without stroking or boring. Compare this to its American cousin, the EJ257. The 2.5-liter came with an open-deck design that was notorious for cracking cylinder walls when pushed beyond about 400 horsepower. The EJ207, despite being smaller displacement, could handle significantly more abuse precisely because Subaru over-engineered the block structure. This is why serious Subaru builders hunting for maximum power often import JDM EJ207 short blocks and mate them with USDM cylinder heads. You get the strength of the semi-closed deck with the larger valves and improved flow of the 2.5-liter heads. It's the best of both worlds, and it's only possible because Subaru built the EJ207 to withstand punishment far beyond what any reasonable street driver would inflict. The WRC connection is impossible to ignore. While rally spec engines were heavily modified, they started with EJ207 architecture. The fact that Subaru chose to give version 7 and later street STIs forged pistons and semi-closed decks speaks volumes. They weren't building a street car that could be modified for racing. They were building a race car that happened to be street legal.
Here's where things get interesting. Every engine we've discussed so far was purpose-built for performance. But what if I told you one of the most overbuilt engines to come out of Japan was originally designed for pickup trucks and family sedans? Meet the KA24DE, the engine that powered the Nissan 240SX from 1991 to 1998, and the motor that an entire generation of drifters learned to love despite initially hating. The KA24DE started life as the replacement for Nissan's aging Z24 engine, first appearing in light trucks and the Nissan Altima before finding its way into the 240SX. With its 2.4-liter displacement, cast-iron block, and DOHC setup with 4 valves per cylinder, it produced a modest 155 horsepower and 160 pound-feet of torque. Not exactly thrilling numbers. American buyers felt cheated. The Japanese-market Silvia and 180SX got the legendary SR20DET, a 2-liter turbocharged 4-cylinder producing over 200 horsepower. We got a truck motor. The forums erupted with complaints. SR20DET swaps became the default modification path. The KA24DE was dismissed, mocked, and written off as the penalty for buying a 240SX in America. But something funny happened. As the years passed and people actually started modifying KA24DEs instead of ripping them out, they discovered something remarkable. This engine was absurdly overbuilt. That cast iron block? It's thick, really thick. The cylinder walls can be safely bored and honed repeatedly. The crankshaft runs in beefy main bearings with a fully girded design in the 240SX application, meaning the main caps are connected together, providing rigidity similar to much more expensive racing blocks. The factory connecting rods are forged. Read that again. In 1991, Nissan was putting forged connecting rods in a base model Sport Compact's naturally aspirated engine. The bore and stroke are a square 89 millimeters each, providing excellent balance. And perhaps most telling, the engine features piston oil squirters, just like the 2JZ GTE. This is not the specification list of a truck motor. This is the foundation of a serious performance engine. Kenji Sumino of GRETTI, one of the most respected names in Japanese tuning, said it best. I built my first KA in 1996 because I wanted to be different and believed it was a better designed engine to make big power. I still believe this is true to this day. Here's the reality of KA24DE builds. Slap a turbo kit on the stock bottom end with proper engine management, and 350 to 400 horsepower is easily achievable. Build the head with aggressive cams and port work, upgrade to better rods and pistons, and you're looking at 500 plus horsepower. Full race KA builds with stroker kits pushing displacement to 2.7 or even 3 liters have produced well over 1,000 horsepower. The displacement advantage over the SR20DET becomes obvious with forced induction. That extra 400 cc's of displacement means more air volume per stroke, which translates directly to more torque. And in drifting, where low-end and mid-range torque matter far more than peak horsepower, the KA's broader power band is actually superior. Professional Formula Drift teams that started with SR20DET swaps began reconsidering. Some switched back to built KA24DEs. The cost was lower, parts availability was better, and the power characteristics were more suited to drifting. You didn't need to keep the engine screaming at 7,000 RPM to make power. The KA pulled hard from 3,000 RPM onwards. The irony is beautiful. Nissan built an engine tough enough to survive decades of abuse in commercial trucks and then dropped it into a sport compact where it had more structural strength than the turbocharged engine everyone wanted. It took the aftermarket 15 years to realize what they had. This is the ultimate sleeper story, not a car, an engine. One that was dismissed, underestimated, and mocked, only to prove itself as one of the most cost-effective platforms for serious power. The KA24DE might not have the cachet of a 2JZ or the mystique of an RB26, but ask anyone who's actually built one properly, and they'll tell you, this truck motor is a giant killer.
So what ties these 5 engines together? What makes them truly overbuilt? It's the engineering philosophy. Each of these engines was designed during Japan's bubble economy era, a time when cost-cutting wasn't the primary concern. Engineers were given the freedom to over-spec, to forge components that could have been cast, to include features like piston oil squirters in engines that would spend most of their lives nowhere near their limits. These engines were built with margin. Excessive, absurd margin. The kind that means when enthusiasts inevitably start pushing double the factory power, the engine just handles it, because it was always capable of handling it. The 2JZTT with its iron fortress, the RB26DETT with its motorsport-grade internals, the EJ207 with its semi-closed deck and forged pistons, the KA24DE, the truck motor that turned out to be a wolf in sheep's clothing. These are the blocks that refuse to die. They're still out there in garages around the world, making more power today than their engineers ever imagined.
because those engineers built them to survive anything. That's Japanese overengineering at its finest. And that's why these engines will never be forgotten.